Okay, so just shoot a question out. Everyone's muted unless you need to ask a question. Okay. All right. Now, I'm only going to spend just a moment on temperature conversions. We don't tend to do this a lot. Ironically, at VCA, our thermometers were in Celsius. So we would take the dog's temperature and it would be in Celsius. We'd have to convert to Fahrenheit to record the dog's temperature. So really, we tend to go by Fahrenheit in the United States. But this is within the metric system. So we're talking about freezing, boiling. If we look at a thermometer, okay, we're talking about boiling point in Celsius has a boiling point of 100 degrees in Fahrenheit. We're talking about 212 degrees. Where freezing point for water in Celsius would be 0, we know that water freezes at 32 degrees. If it's 32 degrees outside and it was raining, we might go from that rain to like ice. So we work on a Fahrenheit scale in the United States. If we talk about the conversions, and they're listed here, Celsius is equal, you've got 32 divided by 1.8. So if we go through here, and if we work through these problems here, 25 degrees Celsius, well, if we want to go from Fahrenheit, you're going to put 1.8 times whatever you got in Celsius and then add 32. Now, quite often we're going from Celsius to Fahrenheit a little bit. Very rarely do we have to go Fahrenheit to Celsius. Most of the time you might work with the thermometer, like I said, that for some reason gets in Celsius, and then we have to convert to Fahrenheit. So if I have 25 degrees Celsius, okay, I'm going to 1.8 times 25, okay, plus 32 would give me 72 or 77 degrees Fahrenheit. If you look at the notes page of this PowerPoint, it works out the problems for you. So if you can, I know on the screen, I think you can see it right here, 85 degrees Fahrenheit. The first thing that you would do is you would subtract 32 from 85, which would give you 53. And then if you have 53 divided by 1.8, you should get 29.4. Now let me pull up my calculator real quick. So as I said, 53 divided by 1.8. Yes, and that gives you 29.4. And I will just tell you, like I said, clinically, they should be in the notes page, but most of the time, like I said, you're going to have a thermometer working in Celsius and you have to convert their temperature to Fahrenheit. Because when we list normal temperature in animals, it's Fahrenheit, 100 to 102.5 Fahrenheit. Now, getting into really the nitty gritty is when we have to do dosage calculations. So typically, this is when the veterinarian gives us an order. They might write it down or tell you, I want to give this dog 4 mg per kg of propofol, or I want to send it home on 5 milligrams per pound of metronidazole BID. So if you remember that on the test when we had that whole formula written out, most of the time we're starting with the dosage. The dosage is how much of the drug we are giving per unit of body weight. So 5 milligrams per pound means that dog is going to get 5 milligrams per pound per 1 pound of body weight. So if a dog weighed 5 pounds and they wanted 5 milligrams per pound. It's 5 milligrams times the weight in pounds. 5 times 5, that dog would get 25 milligrams. The 25 milligrams is the dose the animal is going to receive. So remember the difference between dosage and dose. Dosage is how much drug per unit of body weight. Dose is what the animal is going to receive daily as the medication or the one-time dose. Now, it's usually either mgs per pound or milligrams per kilogram. Like I said, more people are moving to mgs per kg. Old school people like me worked mostly in pounds. Now it's mostly milligrams per kilogram. And then the route, 5 mgs per pound PO, 5 mgs per kg IV, 5 mgs per kg IM. So you're going to need the frequency and duration. How many days are we doing it for? Is it a one-time dose? Is it BID for 5 days? The weight of the patient is the first thing you need. Also, the concentration that the drug comes in. And most of the time, the technician is the one that does the dose. Now, one thing that you will start to get good at, or you need to start to think about, is when you do a calculation, does that sound like the amount of medication I would give an animal? The more experienced you become, the more this will make sense. I'm going to give you just a weird example. I made banana bread last night, okay? I had a recipe. Now I've baked plenty of times, okay? I'm old. I read the recipe, and in my head, I thought I read like 2.5 cups of butter or something. And then I look at my butter, and I'm like, wait a minute, that's like 2.5 sticks of butter. That can't be right. And when I go back to the recipe, I read the cups of flour as the amount of butter. But I literally almost grabbed the butter and put in 2.5 cups. But my brain triggered and said, that doesn't sound right. And I stopped myself. Now, the reason I did that, I've made bread and cookies and things before. That triggered me to go, When you guys are doing a test, and quite often when you get into pharmacology too, you're going to be given problems to calculate medications. It will literally be on every test. There will be math on every test. It will happen in anesthesia. But I will get someone that says, give 5,000 mils of propofol to this cat. Okay, I'm like, your average cat's about 10 pounds. 5,000 mils is 5 liters. That would absolutely kill the cat, number one. Number two, it's almost impossible to draw up 5,000 mils of propofol. So what I try to get you guys to do when you do this math is look at what you're calculating. Sometimes we give you a patient. Now, sometimes with a straight up math quiz, I'm not going to give you a patient, but in pharmacology too and in anesthesia, I'm going to present it as a case. You have a 10-year-old Shih Tzu coming in for a dental, blah, 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 calculate, blah, 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 blah. So I'm going to present it in a case format. I want you to start to think clinically when you do this math. You know, if I have a 150-pound Great Dane and you have this really big volume, probably right. If I give you the little 5-pound Chihuahua, it's probably going to be smaller dosing. So start to put that in your head. When we calculate the dose, one of the first things, like I've told you I do, when I take in a patient, some scales weigh in kgs, some scales weigh in pounds. The top of the chart, I always put the weight in pounds, and then I convert it to kilograms. You take pounds, you divide it by 2.2. That is math that by the time you leave our building, everybody should know how to do that without looking at a book and telling me, how do I convert pounds to kgs and vice versa? If you have the weight in kilograms, you multiply by 2.2. Okay, vice versa. When we do the problem, we're going to first determine the dose in milligrams. So if I say 5 milligrams per pound and I have a 5-pound dog, that dog needs 25 milligrams of drug. Okay, that only tells me the milligram. What is the patient going to get? So foundation 3, is the dose going to be in a tablet form, mil form, units? If we're working with units, it's insulin. Insulin does not go by mils, insulin goes by units. Okay, so if I need 25 milligrams of drug and I go to the cabinet and they want tablets and there's 25 milligram tablets, I know that dog is going to get 1 tablet. The dose is 1 tablet because milligrams, he needs 25 milligrams, I have 25 milligram tablets. If he needs mils and the drug is 25 mgs per mil, I know he's going to get 1 mil because there's 25 milligrams in 1 ml. Okay. The next thing we determine is the total number of doses. If the dose is 5 milligrams per pound, BID for 5 days, okay? 5 mg per pound, 5-pound dog, 25 milligrams. I said it was 1 tablet, right? But he needs it twice a day for 5 days. So if it's 1 tablet is 1 dose, but he needs 2 doses a day, I need 2 a day, and I need 5 days worth. 2 times 5, I'm going to send home 10 tablets. And that is the whole regimen, okay? So we started with mgs per pound. What drug do we have available? How often are we giving the medication? And that's how we calculate the whole problem. If it's a liquid, then we would have to figure out how many milligrams per ml, because liquids are usually measured in milliliters. So how many mils am I going to send home? Or how many mils am I going to give IV 1 time in the hospital? So again, we've kind of been introduced to this, so we'll go over this again. If I'm going to do it once a day, it's 1 dose a day every 24 hours. So if I'm giving BID, 2 doses a day is every 12 hours, T3, QID 4, and then occasionally, like when we get into prednisone. Prednisone is a steroid that we wean. There was a period of time where dogs only get a tablet every other day. Sometimes we go every 3rd day, and that would be every 72 hours. Okay, but for right now, we'll focus, this is like the common interval. So if we're going to calculate, we have to know the dosage of the drug. How much per body weight? Mgs per kgs, that's grams per pound. I mean, most of the time, mgs per kg or mgs per pound is what you're going to do. Occasionally, we work in grams. And then you have to know what is the concentration of the medication you're using. So the weight and dosage must be in the same weight of measurement. If the drug is mgs per kg, you can't leave the patient's weight in pounds. You have to get it into the same unit of measure. And something to know, pounds is always more than kilograms. An 80-pound dog is usually around 40 kilograms. That's rough dividing. If you divide by 2 in your head, it gives you, you have to do 2.2 to do the math. But always giving you a frame of reference. Usually kilograms are about half the amount of pounds. If you're working with, you know, the little guys, exotics, these are usually weighed in grams. They in a little gram scale. And then remember, not all of your drugs are in milligrams. Could be liters, units, micrograms, grains. That's where your conversion factors come in. So we might be sending home medication, and then we have to send it home in a different form, and that's why we have to convert it. So we're talking about the same mass of drug per weight of the animal, 10 mg per kg, 1 gram per pound. Now, sometimes there is a dose range. A dose can be calculated anywhere between 1 and 3 milligrams per kilogram of body weight. I'm going to give you an example. Well, let me go back for just 1 second. Propofol in anesthesia is normally 4 to 8 milligrams per kilogram. That is standard range for propofol. How we pick, I get into that more in depth in anesthesia, but 4 mg per kg is low. If I have a really old dog, they're very depressed, I'm going to go low. If they're super hyper, very healthy, I want to knock them on their butt, I'm going to go higher, okay? Veterinarian is going to help you pick. There's patient factors that help us determine, you know, my doctor's not going to say, let's do 1 to 3 mg per kg. The doctor would have to, I'm going to be like, which one do you want? 1 mg per kg, 2 mg per kg, or 3 mg per kg? Okay. That is their job to tell you where in that range. But if we had a range, what would a 15 kilogram animal receive? Well, if I do 1 mg per kg, that would be 15 milligrams. If I did 2 mg per kg, that would be 30. If I did 3 mg per kg, that would be 45. Now, like I said, most of the time the doctor is going to tell you where in that range they want the dosage. But you could certainly know that the dose that animal is going to receive is going to be anywhere from 15 to 45 milligrams. That's all that problem is showing us. Now, if we're talking about the concentration of the drug in a liquid, for example, a multi-dose vial can have a concentration of 10 mg per mil. Okay, that means for every mil in that bottle, there is 10 milligrams in there. If there is a range on the homework, I want you to calculate the range just like I did on that problem. Use the low end, calculate the low end, calculate the high end, and that is your range. Does that make sense, Shelby? Low to high. You don't have to calculate the middle. You could just calculate, just like on that problem. Yep. Okay. 1, calculate the high. That's your range. Okay. If I have a medication, a multi-dose vial, it means 1 ml contains 10 milligrams. If I look at the whole vial, okay, say the vial is 5 mils. Or let me go back a second. Sorry. If I had a drug and it was 10 mg per mil and I had 10 mils in that bottle, how much total drug is in that bottle? Anybody want to throw it out there? I have 10 milligrams of drug and I have 10 mils in a bottle.
100.
Yep. There is 100 milligrams of drug in that bottle, total volume, total. For every mil, there is 10 milligrams. So if a dog gets 2 mils, how many milligrams did he get? Megan?
20.
Yep, 20. Because 10 mg per mil, dog got 2 mils, 2 times 10 is 20. Okay. Now, sometimes, and this drives me nuts, sometimes drugs get sent to us and they will say this vial contains 250 milligrams per 5 mLs. So I have to figure out how many mgs per mil that is. So you literally divide 250 by 5, which would give you 50 milligrams per mil. Again, you need to break these down to their simplest form. Because when you write that, when that medication that we give an animal is put into a chart, we need to put how many milligrams they got, how many mils they got. You cannot just write mils because, or you cannot just write dog got 1 tablet. How many milligrams are in that tablet? Sometimes drugs have varying concentrations. So I don't know. Metronidazole comes in 250 milligrams or tabs, 500 milligram tabs. Also comes in liquid that's 62.5 milligrams per mil. So you have to write down the proper amount. If I have a 22-pound patient that needs 2 milligrams of a drug, and hopefully you can see it. Can you guys see that math in the gray box under the screen?
Yeah.
Okay, good. So right now, I got to convert first, okay, because it's 2 mg per kg. So 22, you divide by 2.2, then that tells me right there my patient is 10 kilograms. The dog needs 2 mg per kg. So I take 10 kilograms times 2 mg per kg, and I get 20 milligrams. So right now we're going to work through this problem. So now I know my patient needs 20 milligrams of a drug. How many tablets is the owner going to give? Well, we have to figure out what is the strength of the tablets we have available. Say, for example, now a lot of times you go to the shelf and a drug comes in multiple different, like I just told you, metronidazole comes different ways. This clinic, the tablets come in 40 milligrams, 80 milligrams, and 100 milligrams. And they're scored, so you can break them. They have that little line in the tablet. You divide the patient dose by the strength closest to the dose. So what you're going to do, I can't write in that gray box. Okay. The best bet here is probably going to be the 40 milligram tablet, because if I cut that tablet in half, that's 20 milligrams. Does everybody understand how I got that? I would, so 40 divided by 20, you're going to get the half a tablet. 80, there's 4 20 milligrams in that. And that would be quarters. And then 100, you couldn't really divide that tablet. So you're going to have to try to find the tablet that's closest. Now, say we need, but what if the animal needed closer? Okay, Tori, that's a good question. Oh wait, there's lots of questions popping up, sorry. So when it asks an amount to use in there, is it 250 or 500? Which do we use? For Rachel, that question, it depends on what you calculated. For a 50-pound dog, it would depend on the dose you calculated. Yes, Rita, that dog needs 20 milligrams every time he gets a dose. So that means it could be 20 milligrams twice a day. It could be 20 milligrams 4 times a day. It could be 20 milligrams so that's 20 mgs is the dose, and then the doctor would say, how often do you want that dog to get 20 milligrams? SID, BID, does that make sense, Rita? How often you'd be given that 20 milligrams. And that's how you figure out how many tablets you send home. Now let me get to Tori's question, because this is a good question. You don't always calculate everything super pretty, like 20 and 40 and 50 and 100 and whatever. If you calculated 50 milligrams and they're only come in the 2040s, then the doctor would decide, are we going to round up in the pill or are we going to round down? If it's like an antibiotic, we might round to like 60. Or Tori, if it figures out better for the pill, the doctor might say, let's go ahead and do 40. Because obviously 50, we can't send home 50 milligrams if the tablets come in these 20s, 40s. Does that make sense? It's animal size and drug and condition. Because like I said, an antibiotic is super wide range of safety. You'll probably round up. But some antibiotics cause diarrhea. Metronidazole causes sedation. So sometimes a drug like metronidazole, we don't want to go up too high because there's side effects of the drug that we would be better off going lower on the patient. That would be safer. Drugs like chemotherapy have to be very close to the dose. But there's drugs like antibiotics or sometimes syrups or, worming medications. We can just go up. So hopefully Tori, and that's a good question she asked, is when, and sometimes I'll go to my boss and I'll say, hey, this is what I calculated. Do you want me to go up or down? And he'll be like, oh, go ahead and use these tablets. So you always have your veterinarian there to help you with that calculation. Does that answer your question, Tori? Okay. Now, dose and mill. If the dog needs 20 milligrams, how many mils is the owner going to give? We have to know the concentration in the mils. If a drug is 10 milligrams per mil, okay, here's the math underneath. You need 20 milligrams. I'm sorry. Yeah, you need 20 milligrams, and it is it's 10 milligrams per mil. You're going to divide 20 by 10, and that's going to give you 2 mLs. So that patient would get 2 mLs. If the tablet, okay. So again, you have to divide in that case, and it would tell you how many mils your patient needs to get. Units is a little bit different. And units, we first get into what does the animal need? And then we have to divide by the concentration mils. So let's say a 1,500-pound patient, which we're probably dealing with a horse or a cow, needs 30,000 units per kilogram of a drug. Concentration is 500,000 units per ml. The first thing we want to do is get pounds to kilograms. Okay, so in this problem right here, 1,500 pounds divided by 2.2, the patient is 681.81 kilograms. Now, it's telling you we need 30,000 units per kilogram. Okay, so 681, 30,000. This is the amount of units that our patient needs. 20,004,054,545. I know this sounds crazy. Follow me. We know that the concentration is 500,000 units per mil. So we know we need this many units. We're going to divide by 500,000 units. We need 40.9 mLs. And again, I'm going to guess if this patient is that big, we might just say 41 mils, but that's up to the doctor. So you need the concentration in units per ml in this patient. But the very first thing you have to do, get that patient out of pounds and get the patient into kilograms. There's a few drugs that come, here's heparin, is 10,000 units per 1 ml. So again, the dose, when you look up a dose of heparin, it's going to tell you how many units per kilogram, but then you're going to be giving mLs. Pen-G, common antibiotic given, it is right on here, 300,000 units per ml. Another drug that is units per mil instead of milligrams. And you would record units. When you put this in the patient chart, you would write it as units. Okay, so we're always going to not clear out the calculator. Okay, you have a 50-pound dog, and the doctor wants a milligram per kilogram of diazepam. How many mgs is the patient going to get? Okay, first thing we have to do, and also diazepam is 5 milligrams per mil. Okay, so I have the dosage, 1 mg per kg is my dosage, and then I have the concentration of my drug. It's 5 mgs per mil. So, oops, let me go back, sorry. What we're going to do, the first thing under here, 50 divided by 2.2 in the gray box is 22.7 kilograms. That's the weight in kgs. 1 mg per kg, 1 times 22.7 is 22.7 milligrams. Dog needs 22.7 milligrams. That's the first thing I would write in the chart. Second thing is it is 5 milligrams per mil. So I'm not going to give this dog, this is a common mistake and this can kill a patient. If you were to draw up 22 mils of diazepam, you could put that dog into massive respiratory arrest. So your milligrams should always be higher than your mils. If you do a math problem and your mils are higher than your milligrams, you probably went the opposite way. It's a common mistake that happens, but that's why we double check math. So 22.7 milligrams is going to be divided by 5. You divide it by the concentration of the drug. 22.7 divided by 5 gives you 4.5 mils. So the patient received 22.7 milligrams, 4.5 mLs IV at 3 o'clock, for example. Do another one. You have a cockatiel that's needs piperacillin 100 mg per kg. The bird is 80 grams. How many milligrams are we going to give? And piperacillin is 50 milligrams per mil. So if we look at this, we got to get 80 grams into milligrams, okay? We know by our conversions that 1 gram equals 1,000 milligrams. So what we do, this is a simple move the decimal, okay? 80 grams times 1 kg per 1,000 grams is basically I have my arrow on the bottom here, 1, 2, 3. The bird is 0.08 kilograms, okay? So you can divide by 1,000 or you can move the decimal. The bird is going to get 100 mgs per kilogram. So 100 times 0.8 is moving the decimal, also 2 spots. This bird needs 8 milligrams. 8 milligrams of drug, and then, it's 50 milligrams per mil. So you take 8 milligrams and you divide that by 50, the bird is going to get 0.16 mLs. And you can see in this problem, my milligrams is more than my mils. So it fits our rule. Let me go through another one. Doxapram, 7-pound cat, dose is 1 to 5 mg per kg. DVM ordered you to draw it up. It's a 20 mg per mil concentration. Okay, the first thing they do on this problem below here is 7 divided by 2.2, 3.18 kilograms. 3.18 times 1, now that would be 3.18 milligrams. They rounded to 3.2. 3.18 kilograms times 5 is 15.9. So the dose range for this cat is 3.2 milligrams to 15.9 milligrams. And it's a 20 milligram concentration. But the doctor says, okay, 3.2 to 15.9, let's give the cat 12 milligrams. So 12 divided by 20 gives me 0.6 mLs. And I know we're getting close to time, but let me finish something here. Calculating the total dose the patient gets the entire time they receives it. How much the animal needs per day, and then how many days they're going to receive it. Sometimes we need to calculate this. Some drugs have a cumulative effect, and we want to make sure your Plum handbook, I'll get to that in 1 second, Rachel, but if in the Plum handbook you have a range, and they'll say total dose this animal should receive over 10 days or over a treatment should not exceed this amount. So basically, if you have a drug, 20 mg BID times 7 days, and your clinic carries the 40 milligrams tablets, okay? So that means this bird is getting, or their patient, sorry, 20 milligrams twice a day, 40 milligram tablets. This means this dog gets a half a tablet twice a day, which is equals a tablet a day. They're doing it for 7 days. Then the total is 7 tablets total. Actually, I need to pause here. So what is the answer if you have 6% and grams per 100 mils? So if that's on the homework, I can jump ahead and look at the percent problem, okay? Let me get to percent concentrations. Okay, so you have 6% to grams over 100 mils. When you have a percent solution, if you have a 6% solution, that automatically means 6 grams for every 100 mils of drug. But the problem is we need to get that to milligrams of drug. So 6 grams per 100 mils, let me type it out down here. 6 grams per 100 mLs is equal to 6,000 milligrams per 100 mLs, which is equal to okay, I'm going to give you the shortcut version to this. There's a shortcut to percent sun. Let me give you an example. Lidocaine comes as 20% solution. Most lidocaine comes as that. If I want to do percent solution, it's 20. If it says 20% on the bottle, that means 20 grams per 100 mLs. The shortcut is to add a 0. So 20% would be 200 mg per mil. 5% is 50 mg per mil. 1% is 10 mg per mil. Do you see what I'm doing there? So 6 grams per 100 mLs is 6,000 milligrams per 100 mLs, but you have to simplify that. If you divide 6,000 by 100, you get 60. Or you cancel out the zeros. Do you see if you cancel out those 2 zeros and those 2 zeros, you're left with 60 mg per mil. That's the short version. I'm going to come back to some of this tomorrow so we can talk about the rest of this. For those that are still on here, do you have any questions? Yes, so if you have, the dog needs 272 milligrams. The closest to that is going to be the 250. You would probably round down, and your best choice is to use the 250. You wouldn't want to do a 250 in like a sliver, if that makes sense.
Okay. Yep, that makes sense. Thank you.
Yep. And like I said, there's metronidazole is a drug that has a super big or super wide dose range. So when we calculate that drug, we have wiggle room to round up or round down. Now, I will tell you metronidazole, to go from 272 to like 1.5 is, I mean, I've had to write that out. If you have a 250 tablet and you use a half, that's 125. Should we give this dog 325 milligrams, which is 1.5, or would we go round down? Metronidazole can make them drowsy, sedated, cause ataxia. And in some patients, the doctor's like, let's round down. I don't want to go up and risk those side effects. So sometimes it depends on the drug and the patient factors, what you're treating, how many side effects are associated with the drug. So
Okay.
from a math perspective on it, you want to go with the closest, easiest tablet. In a clinic, there is a chance you might do 1.5. You know what I mean?
Okay, so on
Potentially,
the homework, just go to the closest.
correct.
Okay, I can do that.
Yeah.
Okie dokie.
Yes. And Carly, I am going to resend as soon as we end. I'll resend to everybody the notes to make sure
Are
everybody.
we good to get out of here?
Huh?
Are we good to go?
Oh yeah, you're good to go. No, I'm sorry. If anyone's
No,
in
you're fine.
here, I can answer. You take off. The homework. I want to make sure it's done, but if you have a question, if you have like a few blank on the homework, I would prefer to have it due so I could just make sure everybody did it, but I do want to go through some of the problems tomorrow. So if you have a few blank, it's not going to be the end of the world as long as you have the majority of it done. So Rita, I do want it submitted before class, but like I said, if you have a few blank that you're having issues with, you can leave it blank and we'll discuss it during class. I don't know if Rachel's still here.
I had a question about number 20.
On number 2.
20.
Oh, is that homework 1 or homework 2? Sorry.
Oh, 2.
2. Okay, let me get to that question. Sorry. Okay, go ahead.
I had a question on B. It says how many tablets should be dispensed, but it doesn't say what the strength of the tablets.
Oh, well, so it says amoxicillin comes in, hopefully it says it on your paper. Amoxicillin comes in 250 milligram scored tablets. How many tablets should be given at 1 dose? Do you have that on your paper?
I don't. I might have got it cut off. So 250 milligrams, 4 tablets.
Yes.
Okay.
Sorry if that's not on, it's on my paper, so sorry about that if it's not. Yes. And so you should have had calculated this cat needs 120 milligrams.
Yeah.
And then, so then you would break that tablet in, sorry, there's a little gnat in here. You'd break that tablet in half because that's supposed, yeah.
So it'd be 7 tablets for 14 days.
Well, but then it's BID.
Oh, okay. Yeah.
Yep, so you just double it. Yep. There you go.
Okay.
Sorry that you didn't get that vital piece of information.
It's okay. Thanks.
Uh-huh. Any other questions